Here's a system of equations, and you must solve this by graphing it. Solve by graphing. And if you're going to graph an equation, you want to make certain that it is in this form, y equals mx plus b. So do that to the first one. Your first equation, 5x equals a negative y plus 12. You want y by itself. The easiest way to do that in this equation is to just move it to the left. It becomes positive. And move the 5x to the right, it becomes negative. So you have changed that equation to y equals negative 5x plus 12. You want y by itself. Then we have to change this one. X equals negative y plus 8. Again, it's just easy to move the negative y to the left and make it positive, and then move the x to the right, make it negative. So there's not much of a transformation to do here to this. We will go to the next page and graph both of these and find the intersection point, which will be the solution to that system for x and y. Our first equation was y equals negative 5x plus 12. So let's go to plus 12 and make a dot. We have to go down 5 and to the right 1 for the slope. So 1, 2, 3, 4, 5, and over 1. 1, 2, 3, 4, 5 over 1. I have to keep going with this slope because in this app, you start the line in one place and you can't stretch it. You just have to start it at an end point. So that should be enough. And I'll go to the line, start here, and there it is. That's y equals negative 5x plus 12. Okay, in red we will do y equals negative 8, or not negative 8, but negative x plus 8. So we go to 8, make a dot. The slope is negative 1, so down 1 to the right 1. And I have to start this at the end of the graph, at least a border of it, to make my line, and here it goes. We need arrows. And this one was y equals negative x plus 8. The solution to this system is where they intersect. The intersection point is here. And if you graph this neatly with a straight edge, then you have no risk of missing the intersection point, or at least the true one. So what is this point that they cross at? 1, 7, yeah, 1, 7. So that means x equals 1, y equals 7. You have solved that by graphing. You want to solve by substitution. Whenever you look at a system of equations and you find that one of your variables has already been isolated, in which equation, 1 or 2, do we have a variable that's already been isolated? 2, yeah, and it's the y. So that means whatever y is equal to, which is 3x minus 20, that 3x minus 20 can be put in for y in the other equation. Instead of writing y, let's write 3x minus 20 and then plus 4x equals 29. This has been substituted in for y in the first one. And once you substitute in, you should only have one variable to worry about and to solve for, and that in this case is x. So let's solve for x by simplifying like terms. 3x plus 4x is 7x. And then we still have a minus 20. Now move that minus 20 to the right, make it plus 20, and you get a 49. divide the 49 by 7, you get an answer of 7. Don't stop there because that's not the last answer. You still have to solve for y. You can plug this solution here for 7 into y here. Or to solve for y, I should say. You're plugging that in for x in that bottom equation. So y equals 3x minus 20. So we're going to write 3, and instead of x, we're going to put 7. And then minus 20. 3 times 7 is 21. Subtract 20, and you get a value of 1. So you're going to express your answer as a point, xy. X is 7, and y is 1.